happens is, you want to help me build a spacesuit? Come on up here. I'm going to show you the pieces of a spacesuit. What's your name? Greg. Okay, Gregory. We're going to kind of put together a few pieces of the spacesuit. Here is the first layer after the long underwear. You got that one. Be a good catch. Okay, turn around, face all your friends out there. We're gonna assume you're in the spacesuit and you're a full adult now. The other reason why we don't let kids go to space yet, we don't know how your bones are gonna grow. In space, you lose calcium in your bones. A lot of the astronauts come back have a 1 or 2% decrease in calcium on their bones, or get a little bit more brittle. So we don't know how your skeletal structure will grow. So that's why we want to have a full adult. How tall are you going to be? Okay. Anyway, this is the first layer. This is the bladder. This is the inner tube. You're going to hold this up just like this. Hold it up like this, way on top. That's all around your body. That's your pressure suit. Okay. And basically inside you have breathing oxygen. Outside you have vacuum. That's it. Okay. Then the next 5 layers, you're going to have to hold on to this one too. This is aluminized mylar, white gossamer material. We have a bunch of holes in it. This is all around the suit also. Can you hold on to this now? There you go. Real good job there. Okay. Excuse me. Now, the reason for this aluminized mylar is, when you're out in space, on this side here you have 250 degrees face from the sun, Fahrenheit. Okay, on the back side, when you face deep space, you're minus 200 degrees. Gregory, you are inches away from being roasted and frozen to death. You want to continue this? So this insulation now is like putting you in a flexible thermos bottle. Remember the old thermos bottles you used to take to school were 2 layers of glass? What was between the 2 layers of glass? Vacuum. Yes, you're right. Okay, that vacuum is an excellent insulator. Obviously, we allow space vacuum to get in here, and now you do not feel the hot and cold. Make sense? Now, though, what's your body heat doing? All your body heat in here is now starting to overheat the spacesuit. Now what do we do? Okay, we start to get warm. We pump the heat into the long underwear, and in the spacesuit we have a water tank. We boil water. Who's a cook here? Anybody a cook? Who's cooking the hamburgers this afternoon? Anyway, in space, well, what temperature water boil in Rhode Island? 212 degrees Fahrenheit? What temperature water boil in Denver? About 208 degrees. Temperature Mount Everest? Maybe 150 degrees Fahrenheit. In space, what temperature water boil in space? 32 degrees Fahrenheit. What temperature water freeze in space? 32 degrees Fahrenheit. Okay, we have a special radiator. That will not freeze up. Will your Dodge radiator freeze up? What we do is we pour water into this radiator, and it hits vacuum, and it freezes into a block of ice, somewhat, okay? And now the water, which is now solid, sublimates away directly to a vapor, vacuum, okay? And for every pound of water we boil, we cool your body for 1 hour. So therefore, in a spacesuit for 8 hours, you need at least 8 pounds of water. Are you feel comfortable now? Okay. Okay, now we're going to put the outside layer on. We'll put this away. Face your friends. They're all friends out there. This is the outside. And a friend in need is a pest, right? This is your outside Teflon. It's a beta cloth. It's Teflon, Nomex, and Kevlar. Even though it's got Kevlar in it, it is not bulletproof. How fast would a micrometeorite come at you? What, up maybe 20 miles per hour or per second, okay? So anyway, if you have a microrite heat, a hit, we have to survive at least a pressure the size, to maintain pressure the size of a BB hole. That doesn't make sure you can have a problem with yourself. But you immediately go right. We have never had this. What happens is, to be on the safe side, the shuttle does become, if they're working, the shuttle most of the time try to become, this is a protective meteorite shield. Going this way. So the astronauts try to work here. It is more dangerous on the space station. Okay, now you're just about done there. So that's your spacesuit, okay? Thank you very much. Okay, then we have inside the spacesuit, we have an in-suit drink bag. We attach this to your long underwear. We don't let you come back in for a water drink of water. personally, we don't also let you come back in for a pit stop. We'll talk about that later. Anyway, you can sip water out of here. This is the in-suit drink bag, about a liter or two of water. And also, here's the old Apollo one. Does that work here? Ah, it sticks right there. A little straw. We were following the Apollo missions. Every time the guys were walking the moon, we'd have a crew of engineers and technicians at Hamilton all day for the entire moonwalk, following these guys. We still do that today on the present space station and shuttle walks. We always have somebody at Hamilton assisting NASA. Anyway, we got a call from NASA. Is your backpack, this by the way is a Apollo backpack, I'll talk about more detail, but is your backpack certified for Tang? Remember Walter Cronkite and those guys in Tang? Anyway, an astronaut substituted Tang in his drink bag, and things everywhere leaks. So basically we had to go down to the local supermarket, buy a bottle of Tang, and see if we can cause, because Tang is a very sticky, syrupy type of orange juice fluid. Okay? Anyway, they did not have a problem.
It was not invented by the astronauts.
No, well, another thing, you're not supposed to, I'll talk about that, but you don't drink Coke or Pepsi in space. Now, let's go through that human factor problem. Okay, when you drink, you like Coke or Pepsi? About 20 years ago, they had a Coke Pepsi fly-off. They physically had Coke and Pepsi design a can that could keep the pressurized fluid inside and you can drink in space. Anyway, they went to space and they had the test. Have you ever heard of the results? No. Nobody's heard of the results. Well, here's the problem. Let's pretend this is your stomach on the ground. You drink Coke and Pepsi, it gets down here, right? And you, of course, the dissolved gas of CO2 comes off your body temperature, and you get this pressure bubble on top of your stomach. And of course, you got a what? Burp. And what do you say then? You got it. Okay, that's the way it goes on Earth. In space, due to the dynamics of water, the liquid gets in your stomach, and the gas bubble's not on top. It grows in the middle of the stomach and pushes the Coke and Pepsi back up in your throat, and don't taste so good the second time around. So now, that's why you don't drink I got some space food over here, but you don't drink carbonated fluids in space. And of course, we also work with the Russians, but they did verify they do take vodka in space on the Mir. The Mir, they went up there with vodka. Okay? But vodka is not carbonated, is it? I don't drink. No. Being from Wisconsin, we don't drink vodka. Okay. Okay, now spacesuit. Any questions on the spacesuit? Yes.
Does it have a barf bag in it?
Oh, does it have a barf bag? Oh, what did I say? Okay. No. However, excuse me. I just mentioned before, if you want it, you don't go in the spacesuit for the first 3 or 4 days, right? So by the time you get in the spacesuit, you can do all the gymnastics you want to and get out there and do your thing. So there's no astronaut that has really got sick inside the spacesuit, because if you do, it's a very cloudy outlook on life. Yes?
There was a report on National Public Radio about a month ago about people working on the next generation of spacesuits, yes, which they hope will not be inflated. They described it as sort of like a Spider-Man suit.
Well, okay. Here's the situation. I just mentioned this is a 300-pound suit.
Yeah.
Okay. Basically, that's a zero-gravity suit. And we have also worked on right now. In fact, I've been to Mars and back. But here is Dr. Flush on Mars. That's the Twin Peaks on the Sojourner picture, right? You recognize that Twin Peaks there? Anyway, we have to build the spacesuit to be roughly, to go back to the moon, to have effectively the same weight as the moon. This backpack here, which is a lunar backpack, weighs roughly 75 pounds. They had a Mercy system up here. The whole suit weighs 180 pounds. That was the walking suit on the moon. The present zero-gravity suit, which is 8 hours of logistics, this is only about 5 or 6, has 300. So if you want to go